Hello everybody. In this video I want to do a quick, well, probably not that quick, but I want to do a lecture. And let's talk about authentication and the different type of authentication, the different that authentication authorization is, and how can we actually protect our backend APIs through those. What are usually the different methods possible, where those methods being used mostly. The idea in general is to have a high level understanding about the protection and how to implement it through the APIs. So this will be the lecture part, and the next video will be the implementation part. We will take one of those elements. So here we just it's a practical day pretty much for developers to call protected APIs. We need to talk about identity first. We need then talk about secret, safe, private, and then production recovery matters. And how can we achieve those? Pretty much. So authorization is where convenience and risk collide. Broken authentication keeps showing up because it sits right in the boundary between users, session, APIs, and secrets. The, the idea here is how consumers of APIs are responsible for finding those boundaries safely. And we need to see how we need to protect those parts and be able to enable it in our APIs and how can actually call in a secure manner. Because yes, there's sometimes we have public information, our audience is actually public. We can specify those, but in most of the cases, we need to protect the information behind a login. And that login should be handled in a different manner, just to understand who is actually making the request itself. Now, the difference between an application and an API, REST API, is we are talking about their RESTful section that should be stateless, and how we can actually handle the stateless part in the API per se, right? So every app consumes something protected, like I said, your profile, payments, internal administration APIs, third-party software as a services, that kind of information. Leaks are usually operational. That means if it's not protected correctly, um, you can copy tokens or expose keys, and then you can make calls in the backend in a way that was not designed and not intended to be called at the beginning. And here the consumer shape the blast radius. A secure provider still cannot protect you from shipping secrets to the browser. And we need to be careful this because we need to remember we are shipping JavaScript to the browser, and everything that is being sent to the browser is public on the user side. You can hide a key or a username or something, but if you send that through JavaScript to the browser, there's a way to grab that even when you're not rendering the DOM on the document, the website. But if you send it as a JavaScript, there's a way to get that information, and we need to protect that. And that's where most product teams actually fails. We need to travel how the cryptography is not the main failure mode, is actually the teams and how they implement those. And there's a lot of mistakes that could happen. And the idea is just try to prevent most of those mistakes to be operational. That's one of the reasons that we have not deployed our project's application yet. We will talk about identity, consume, store, how to refresh it, how to deploy, and we will review some anti-patterns here and there. And this is pretty much the agenda for today. I will be talk in general terms about a lot of elements, and then in reality we just will focus in the particular part because that's the scope of the course. But I see the need to actually explain different elements and try to give you guys the guidance for different elements so you can have a broad idea what this actually could be. So the first thing that we need to be here is authentication is not the same thing as authorization. There's two different concepts, and usually we call that out, and we abbreviate as with the four first letter AUTH. Well, in reality, it should be five AUTH-N or AUTH-C because authentication and authorizations are different elements. Authentication provide identity. Authorization check permissions. And the best analogy that I was able to find or to come up with is actually the airport analogy. Authentication is a passport check. That you have a passport, you can go in. Authorization is the boarding pass that grants you seat on a particular flight. So if you go through TSA, your passport is the check, and that will be your authentication. But the authorization will be where you're sitting in one particular plane, and that's what we are going to be seeing here. So what we need to protect are one of the most common mistake that we can have. So API key used to reach third-party providers, those need to be protected. Access tokens that represent current user and sessions, those need to be protected. Refresh token, and say what is an access token, refresh token, we will talk about that later. OAuth state and PKCE certificates for verified issues, those should be protected. So usually the common mistakes that we have here, we embed vendor keys inside the front-end bundles, or treating JWT web JSON web tokens as a input private data that should not be there, skipping some validation for callbacks, or even refreshing the same expired session multiple times at once. All those are common consumer mistakes that we should be prevent. So there are usually four different tools or ways to authenticate. We have the API key, session cookie, beer token, and OAuth 2.0 mostly. Are the most common one. There's a lot other ones, but those are actually the most common ones that we can handle. Um, we actually think we've been using API key before. Um, when we were consuming a specific API, or when we saw the list of API, we saw some of them just require an API key. In making term shorts, API keys are shared secrets that usually used for server to service. That means for backend to backend. Is just to keep it trusted between things that are not be exposed to the client. Session cooking is usually using for backends owns the login session. And you can establish the cookies and the cookie and make those parameters. Beer tokens are more portable credential attaching headers, good for API, but possession matters. We need to take care, and that's pretty much the one that we'll be using. I be the combination between the two and the three for API. And two is when we delegate. That means when we have a Google login or a Microsoft login or a GitHub login, and without those elements, so usually you to other two. That means that you delegate the authentication to a third party, and then you come back with the specific tip that you need. Now, API keys, that's the simplest way, but we need to be careful because an API key actually proves how to request a shape and what front-end distribution turns into secret and public artifacts. So if we expose the API keys, we can be in a problem. API key proves the shared secret identifier and simply to send hard to rotate. That means that is something that doesn't change. Let's say, for example, if you go through a specific API and they'll tell you, well, in order to get this, you need to register. And when you register, we will provide you a specific key. They will notice is who's actually making the calls. And after they notice who's making the call, they can rate limiting and measure your behavior across the board. The thing is, you expose that key to your users, that means that they can install and use it on behalf and do a behave bad using that particular and abuse of the system. And the original provider will think it's actually you because you share that secret. So we need to be careful in that particular element. The way that it works, API key flows through the backend is really simple. Client make a call to the backend, and your backend is the one who actually made the call to the third-party content. And it's usually the is in the XAPI key header, could be one of them, or it could be API key, like different names, or even you can put as a query parameter within that. So there's no real way to actually handle, but the one who makes the call is should be your backend, never your client. So you're using the API key flow, it's just to pull information from other systems. If you're thinking about your project and you need to say, I don't know, you're making a DND database and you're pulling different spells from a DND spell database publicly available. So you make those through your backend and you expose those in your front end without telling your client from where actually they came from or where API key you uses to actually make they came from. Right? Never ship long-lived vendor API keys in your front-end bundles. That's really, really important. An example, aquí we have here, uh, we can have something like this. We have a response that we can actually wait on the page. This is asynchronous. We call it like, for example, API example.com reports. So we call it the reports uh, domain from the examples URL. We'll just get and we send the header with the API key, and we should usually save that in a env variable. We actually don't have anything hard coded in our code. That's really, really important. We need to be really careful. So we usually use an environmental variable. We're talking about those, and we make the call to the key. So here we just making the await, and the response came with OK. We proceed with to get the data. The JSON object is not like this one over here is not OK. We throw the error. So that's just an example of an API call. And it should be in JavaScript, right? We just do a wait page and we send the headers in this particular as XAPI key. Could be a parameter, could be a different elements, but let's say that they actually call it like that. So where we storage for those API keys? Well, front-end source code, uh, nothing secret, so we need to be very careful. Environment variables on servers, vendor keys and service credentials are actually cool. We can use secret manager, that's high value production credentials, or client local storage, something that is not secret or preference only. But you will say, well, yeah, if we expose it, but what about we saving the local storage for the client? Well, you shouldn't put secrets in your local storage. You can put other elements like, I don't know, we prefer dark mode instead of light mode. Or likes the header in a specific site, things like that, like preference only settings or other elements that you trivial in your application, but never a secret per se. So just take this matter. Like front end, nothing is secret. Be careful with that, right? So safe answer what we can actually put on the browser. I was saying before, like team preference, public OAuth client ID without the secret ID, short-lived UI state, like say like the sidebar is open or closed, and that and will accept user inspecting, right? Be careful. A big no. Vendor API. Don't put it there. Refresh token. That's not the where they're supposed to be. Client secrets. Never put those there. Anything will matter from a copy paste from DevTools. And that's what I'm saying. Usually the DevTools is the one that you can handle to grab that type of information. So just be careful. And those are the ones that you shouldn't be calling or saving in your browser. What happened is we push those, well, those will be out there forever. So if for any reason you expose your API keys, well, you need to be careful because it's always in the Git history and it's really difficult to remove from there. It's possible, but it's just difficult to do it. Bots can scan public code and the views start fast. You will surprise to look, for example, how many ChatGPT keys are exposed in GitHub, and you can grab one and use the API. You will be surprised how many people actually do that. So be really, really careful regarding that element because abuse start fast. We have bots that are looking for that information right away, and they start making the call, specifically when your keys are used in a environment that need to be paid. So what happened there? That when you rotate your keys, you rotate now under pressure, and now you need to change everything there. So what we need to do instead? Well, we need to keep secrets because we're using Clover in this way. Clover has secret storage, and we can save those through there. And we'll be doing that in the application. And we can have secret scanning before we publish, just to verify nothing's there. Like if something get pushed, you need to change that key right away. That's really, really important. And assume that an exposed key is already compromised. That's the way to see it. So be really careful. Avoid this, but if that happens, you need to elaborate and do this. So what are the benefits for API keys? Well, as we say before, it's matching to matching calls. Admin integration, internal backups, low complexities. They are not for identity, and they're usually limitation. Once share, I know nothing about what another person can do through that. So just be careful in that. The other part will be, well, what about JWTs? It's a token format, not security shortcut. So JWTs is the the abbreviation of JSON web tokens. And even become because APIs and frontend need exportable, inspectionable sessions artifacts. So the good things about those, they are stateless token architecture, they are header, payload, signature, and bearer usage for storage traceable. There are no server-side sessions through here. And well, we will talk a little bit about the refresh token itself, but usually those are stateless. So that means that your backend understands the token and can decode it and verify if you have a valid session or not. So when you need to scale your backend, it doesn't matter because you can call any of your endpoints on the back and you still have access because most of the time the architecture is stateless. What happens when it's not stateless? So you create the login to a specific server, but when you try to go a second one, it just doesn't work because your session is storing only one server. That is important to have a stateless process that we can push and have that grow in our backend itself. Stay from the browser sends a cookie, stateless, the client sends a self-contained token. And that's it. And we actually be doing a combination of both a little bit. Um, for simplicity, we'll be using local storage for the refresh token, but cookie is the method that should be most used across the board. So a JWT is actually handling three different elements. It has a header, it has a payload, and a signature. A header is something like this. You say like the algorithm that's been used and the type of element, the clone token type signing algorithms. Payload usually contains claims and clients and servers can inspect. And the signature just protects the integrity. If payload changes, signature fails. That's really important. That means is they try to change the payload per se, the signature will make that the whole element will be broken. And it will say this is actually invalid object. That's the pretty cool thing because the signature itself is being created with payload information and with the header information. That will keep readable payload, signaling integrity, better semantics. You can read it, but do not trust client side. You always need to spec. And that's really, really important. So remember the three different parts. Let me clean it up a little bit. Header, payload, and signature. And we will be using the payload to send things like use rating, things like that. Things that can be public without having issue. And it will depend what type of application you have or what type of information you will need to send there. Very much. So an example of a payload could be something like this. I we have a ESS that will be the system user it. We have as the subject over here. Here we have like an ID. Audience. This is for getting the dashboard, let's say, for example. That's that's the full name. We know all of them use. The scope is like the permission. So here you have read profile and read billing, for example. We have expiration, it's a timestamp, when this token expire and when this token was actually being used, created. And those are the different elements that we usually have in a particular payload. So just to understand which are them. Now, all this information is readable. Um, a JWT, a JSON Web Token, is not encrypted data, per se, right? So, and that's the important. JWTs are no encrypted information. They're just simple base64 in a specific format. Do not put user ID, user ID, issuer, scopes, timestamps, minimal identifier context. Never put passwords, secrets, private notes, everything, because those are readable. And now, JWT is not the same as an access token. JWT describes a format. Access token describes a job. Access token is whatever credential the API accepts the authorization. Some are JWTs, some are opaque random strings. So access token could be a JWT or could be something else. We'll be using JWT in this example, but it could be something different. So for example, let's say, well, I want to get my profile. So make a post, a get request to me, and I send my token in, in the authorization header. If this gets validated, we proceed and do the rest of the element. But if this provide me for one, here where we redirect the flow to a sign-in. So this is just a typical API request just to get a particular element, like getting your profile, for example, or getting who you are and verify that your token, who is your token, and they provide that information to you. That way, you have multiple user. If John makes a call to me, it will get John's data. But if Maria does the same, Maria will get Maria's data, even that they pull in the same endpoint, because it will be decrypted or it will came for the particular token authorization. And then we can have the logic on the backend to see what we need to provide to that particular user. So where do we need to save those access tokens? In the front end side. Well, usually um, in memory states are really good. So single tab sessions that reduce persistence. It will be lost whenever you refresh the page. And it's pretty much the standard where for single page application like the one that we're doing right now. So it's really, really cool. It can be redirected from a secure backend session. Now, if we save those in a cookie, that means that the backend manages the sessions and refresh tokens. There is a risk of cross-sign forgery. If the cookie is poorly designed, that means the other side can use the same cookie. You can read it to cookie. If you use local storage, it's convenient, but you exposure that cross-site signing that you can actually get is called from JavaScript and you can put it there. The thing with the session storage is still exposed to XSS. It's like a narrow exposure, but it's not fully secure. So access token will be stored as in memory. And then we will be saving either it could be in HTTP only cookie or even in local storage, the refresh token. And I hope that I'm able to type it. Yeah. Look at that. It's supposed to say refresh there. And those are the ones that we'll be saving here. But the flow for the access token, that one should be in memory only. So practical rules for single page applications. We need to keep short live access token in memory, keep refresh capabilities behind a secure backend, or in cookies, minify data inside the tokens. And UI logs never say that because the cross-site scripting prevents part of the authentication security. So we just need to be careful about that. So we need to pick the right model. Internal like sync job, API keys, for example, single page applications like the cookie flow will be best. Accessible through Google Calendar, the O2 mobile app calling protected API, the bearer token flow. Like it should be different types. Now, we'll be using a combination of a single page application calling a protected API. So because we'll be doing that, we will be using the bearer token flow in our app. That's the part that we'll be using. Mm. So now just to understand, well, what about the O2? Well, when you delegate the access to somebody else, you can have things like resource owner, client application, authorization server, resource servers. And it's a difficult type because let's say that you're the user, you have your user, and make call to your app, and the app send that to the authentication server. It signs the user, and it gives the authorization code to your app. So you're actually doing two different elements. And now without that authorization code in your app side, we can start making backend exchanges. And that backend exchanges can use the Primos the API that we'll be using here. That's a little bit how it actually works. Redirects to provider, user signs in consents, provider back exchange in the codes, and the application called the protected API. That's pretty much the code. So this is the most strong, I would say the best one to use. One of my recommendations is if you don't need to handle authentication in your app, don't do it. If you can leverage that to somebody else, do it like that. But it is important to understand what that means. So the way that we are actually doing in this course is just to let you know what can be used when you really need to have local authentication. But my recommendation is always try to move those to somebody else. Check on what must be the client validate, return the state, callbacks handle, the code change, and request scopes. So this is just an example. You can see through here, like what happened there. So the idea is like you have your provider. Let me just try to, if I should be able to scroll. Let me close it. Yeah, should be able to scroll through here. So the idea is we have assert the state machine of the cookie. We make the call to the provider with the token. We do a post and we send the different information. Usually we set up as a parameter the grant, the code, the redirection URL, things like that. So we go to the provider, make they usually open the login page in their site. You log in, and then you get back to your own application, whatever redirect UI you have. And if everything okay, you return that response. So it's just a simple example. It looks complicated. It is a little bit for the dynamic of that, but that's pretty much how it is. Now, why PKC matters? Authorization code travels through the browser. So without extra proof, a stolen code could be redeemed by an attacker. So whenever you use out, try to use the PKC especially when you are having a single page application. So that's just a way to generate a verifier, hash it, and send that challenge badge. And that's a horrible page. Sorry for that. But that's what pretty much what it does. Access token versus refresh token. So now let's get back to that part. Access token should be short-lived credentials used for normal API requests, and refresh token use a longer lived, and thus for request new access token. So it defers a stronger protection. So the one is to get for daily traffic. The second is to session continuity. That's it. The cool thing is with the refresh token, you should not be able to call any data or your API, but only refresh your access token. That is the one that will provide the information from your APIs. And the expiration, like how that actually happening, because we're talking about access token is short lived and refresh token is longer lived. Well, why? The access token expire fast because if they're stolen, like they really will not have permissions to do anything. Permissions can change, user lost access, things like that. So request a new access token will grant us those particular permissions, and we can make comment right away without the need for the user to log out per se. And rotation becomes a normal. Team building refresh as a standard path instead of emerging path, which improves reliability. That means that you can be using the app and you never know that your browser is using JavaScript to call that refresh token and you're updating whenever it is needed. So when access token expires, what we need to do? Well, it is, and that's also not horrible. And so when the access token expire, the API will return a 401. The first thing we need to do, yeah, this is really horrible. Sorry for that. So if the API returns 401, we need to call retry with the unit request. We need to refresh it. We need to store it and then call it one more time. If it's a second time, give us a 401, so we should go to the login page. Login, right? And I did a mess, so let me try again. So you make the API call, you get a 401. You make that, you save that call. Get a new, through the refresh token, get a new access token, store the access token in memory or whatever you save it, and then you retry that call. And this will make it good. But if you get this one as a second time, that means that you need to exit the loop and go to the login page. I hope that it's a little cleaner there now, right? An example right here. So we have a function called API fetch, and forget about the promise thing and request info. This is like TypeScript, and for everything that is after columns, forget about that. So we have input and initialization, right? Here we can see that we make the response input, try it. If it get a 401, if it's not 401, that means it work. We just return it, like this is what we needed. In flight refresh access token. If it's a 401, that means that we skip this part, right? So we call the refresh token, we annulated the refresh token, get the new token, and we retry with a new call, and that's important, where the bearer is the next token, not the current one. Then with the access token, we return a cache access token, and refresh access token, we just return the new access token thing that we have, right? So now we have the fetch. That means that will be the second call that we need to do. So instead of having the await fetch, we are actually returning a second fetch with the new access token per se, right? That will be like an example of to refresh it. We need to cache the response and make it a second time with a new access token after we are ready. Refresh it. That's pretty much what we need to be doing. Now, if we use Axios, it's a different way. Axios have something. Axios is a client that you can use for a tool to use API HTTP requests. It's pretty neat. They have the concept of interceptors, and that means that it's like a hook that will be in every call. It will be interceptor. Let's retry it pretty much. You can read it in more detail later. So why the queue matters? Well, we need to be careful not to be refreshing the same calls over and over. Like, well, let's say that we have three calls, only one is going to be refreshed and replay the when the new token arrives. That means that we need to keep that in order, because if not, that means that we will have three different refresh when we have the token already expired. Just be too careful how to handle that element per se. We have some nice cases, expected cases, and be careful with bad recovery behavior, right? Now, what we need to do for one or for three? Well, for one means you authorize. That means your access token expire. For three is forbidden. That means you don't have the permission to use. I mean, even when your token is valid, um, that's an authorization issue, no authentication. So just be careful how to handle those. Rest condition to discuss in code review. Just be careful about duplicate refresh, sign out drift, um, clock queue. Client assumes a token is valid longer, like how you need to handle inconsistent between different browser tabs. They have different refresh states. So there are things that we'll need to be thinking in the future. Probably will not be going in details. If we have like another semester that we can have like advanced web design too, probably we can see those elements at a more enterprise level or senior level understanding. But I just put it here just to let you know that those exist, right? Cookies and cross-site forgery, sometimes safer, sometimes just a different risk profile. So when you save your refresh token in a cookie, well, JavaScript cannot handle it because it will reduce the blast of who can actually call it. So it's only your website because it will be hidden from other ones. The trade-off, the browser sends the cookie automatically, matching resource, and those can be cached. And so just be careful about those. So the browser make a call to the API, send the cookie, and a attacker cross-site forgery request if they grant your cookie, if they're able to push it. So we need to have the correct trigger and we need to be handle the TSFR. We need to the way that it's supposed to. So just be careful. There's a different defense that we can use. Um, what about token storage in cookies or on transit, right? So cut off the win when you're back on the session lifecycle. You want refresh capability hidden from browser, but better tokens in JavaScript might be win when the single pass is directed to multiple APIs and must boost my authorization. When you need the excess trade-off and mitigate aggressively, like when you need a portable SDK level token handling across platform, things like that, right? So it will depending where with the case. Mostly we'll be using the one on the left. Now we are deploying to serverless architecture in Cloudflare. So everything is changed a little bit here. So we need to understand a little how those pages are being handled. So started deployment change because the assets are usually like distribution or build folder are the one that is rendering the pages. So server-side secrets for Exchange, those should be using in specific keys and in secret. And I would recommend mostly utilize those in workers and not in pages. So what I mean is our view app will be the SPA, or Hono app will be deployed in a worker, and then we have the what APIs we needed to, but we'll not be using this. So our browser will be creating Vue, our backend and worker will be creating Hono, and those are the ones that we'll be calling between each others, right? When to add a worker, like whenever we need to handle backend API, pretty much as simple as that. So API authorization code review. Just remember, short-lived access token, minimal scope, state, single flight, refresh logic, cache if there's printed authorization logic, and then if it retries around for once, be careful that without one retry, but don't retry everything, because if you fail a second time, you need to abort pretty much. And that's it. So final cheat sheet. Authentication provides identity, authorization grants permission. API keys are shared secrets, JWTs are signed, readable tokens. Do not treat them as encrypted values. OAuth is about delegated access, not just logging with X button. Refresh logic should be single flight, bounded, and invisible when successful. Cookies improve the secrecy in JavaScript but requires cross-site foraging thinking. And Clover page the public delivery put confidential exchange logic in workers or other trusted backends. So review the prompts that we have here, um, and the habits to keep authorization boring in production. So keep in your head, play secrets and trusted runtimes, not in public. Treat readable tokens, convenience state, not confidential storage. Ask in code review where does the secret actually live, what happened in 401, can a third-party site trigger the request, like somebody else called my API, and what would happen, things like that, right? So I hope that I was able to explain a little bit those authentication part, like how those actually work here and there, and I really hope that you like it. If you have questions, when in doubt, please don't hesitate to reach me. In the next video, we will be actually adding the authentication part. We will not handle the authorization. I think that probably is a little bit too much, but we will say like what we need to be done in the authorization part. For now, we just keep the authentication per se. So I hope that you like it. Any question, any doubt, don't hesitate to reach me. Happy coding, everybody.